Good morning once again and welcome back to our class in statics of rigid bodies. So previously we have tackled about couple moments, and on our second lesson for this week we will learn how to simplify force and couple systems, because there are some instances when you can see that a body is subjected to many forces and many couples, and basically you can simplify all those forces and all those couple moments into one single force and one single moment. So that is our goal for this lesson. We will learn how to simplify multiple loads into one single load and be able to solve those kinds of stuff. It's tough way. Why do we do simplification of force and couple? Because sometimes it is more convenient to reduce a system into simpler system. Say for example, you have a beam here, and this beam is subjected to multiple external forces and natay mga couple moments. Again, let's say for example, we have this beam, and this beam is subjected to multiple forces and a couple moment. And for us to be able to simplify this kind of system, pwede din nato i-reduce into a more simpler nga way. So, say for example, this one here, we can reduce this one into a single resultant force acting at point O, and there is also a moment at point O. Okay? Nakagets lang mo, FR, and this is MR. Say pasabutan ni. Ang kani silang duha, they have the same effect nga gibuhat diri sa atong beam. Ang ato lang gibuhat, ato lang gisimplify. Okay? So this is our goal for this lesson. We have to reduce this multiple loadings on the beam, and we will just make a resultant anang multiple nga mga loads. But these two have equal effects sa aning atong beam. Okay? Sige. Let us first imagine a stick. I will teach you this principle so that you can apply this one later on. So I have this stick, and I am holding this stick at this end. Okay? Basta ako gigunit ang stick ani nga end. Okay? And there is a force that is applied in the end of the stick. Now, does this one have a same effect if ako siya ibalhin ang kanang force dire? Yes, it does have. Ako ra gibalhin ang force dira. It still creates the same effect sa akong kamot. Okay? Ngano man? Because, di ba, nagbutang ko anang force. And ang ako gibuhat, nagbutang pod ko anang force dire. Pero nagbutang ko same magnitude, nagbutang ko couple dira gihapon. So, unsay mahitabuan ni? We can just easily cancel this one and this one. Therefore, ang nabili nimo is ang kaning atong force nga naa diri. Okay? Ang ako lang gibuhat, nagbutang ko equilibrium nga force, and then parehas man sila magnitude. So na-cancel ang duha, and then nibalhin ang force diri. That is what you call the principle of transmissibility. Okay? The principle of transmissibility. So again, it just basically means that you can just transfer a force to another location and it just creates the same effect. Diba? Okay. Another instance. How about if I am still holding this stick, and instead of having a force that is going towards your hand, how about kung perpendicular sa imong stick? What will happen? If we are still going to apply the principle of transmissibility, butang yapon ko anang force. So this is your F and this is negative F. Okay? And makancel ni siya, and makancel ni siya. So, kanina lang ang nabilin. Therefore, you can create that one. Okay? But, is this enough? Na parihara ba ang imong effect katong naa siya diri o naa siya diri? No. Why? Because, kung naa diri ang force, naa siya na-create nga moment. Pero inigbalhin nimo ana nga force diri, asa na mga moment? Dapat naa gihapong moment. So that is why, dili lang enough nga ang force lang ang nibalhin by the principle of transmissibility. But also, there is a moment nga na-produce pod tungod adtong force nga gibutang didto. Okay? So that is what you have to take note. And basically, that moment is just your F times D. So this is your F and this is your D. So mo tong moment. Okay? When you're talking about kanang mga forces that are perpendicular sa imong axis, then it is important nga imo hinumdom nga dili lang ang force ang nibalhin, but also na-create nga moment. Okay? Take note. Sige, let's have an example. You have these three forces, 1, 2, and 3. The goal of this problem is for you to replace all these forces into a single resultant force and a couple moment. Okay? Acting at point O. Okay? So, ang goal sa problem, ato i-simplify ni siya into a one resultant force and then ang iyang couple moment about point O. And take note, bisag ato siya gi-simplify, unsa may iyang mahitabo, it still creates the same effect sa bisan gi-simplify siya. Okay? Sige. So, mao na atong goal. Unsa man atong una buhaton? We have to determine the resultant of the three forces. Can you still remember how to determine the resultant of multiple forces? Atong buhaton is to do summation. And di man ni siya sayon ni summation kung di na to kuha ang components. So, ato siya isum sa iyang mga components x and y. Okay? So, summation of forces along the x. And again, take note, we have to assume a positive nga direction. Ang atong positive direction, let's say, going to the right. So, this symbol here, nag-ingon lang ko diri nga ang atong right nga direction is positive. Okay? Is equal to. So, when you sum the forces along the x, then you will get the resultant force along the x. Okay? And then, equals to. Sige, pinaspasay na ni atong pag-solve ha. Kanitaon na. Sa mani? 3 cosine 30 degrees. Sakto? Okay, diba? This is your x component. And mo na itong gipangita. And positive siya because it's going to the right. So, 3 cosine 30. Next, dito sa 5. So, this is plus. Kay still going to the right ng iyang component. So, this is 3/5 times 5 kilonewtons. How about this one? This is acting vertically. So, therefore, this one doesn't have an x component. So, this is 0. So, plus 0. Okay? Sige. So, what is your FR? X. This is 5.598 kilonewton. So this one is a vector, it should be going to the right. Okay? So this is your resultant force of the three forces on the x component pa lang sa atong resultant. Ato na punta sa y. Summation of forces along the y. And karon, mag-assume ta nga ang positive direction is going up. Okay? So, ang up, ang positive direction ani. Equals to the resultant force along the y. So, this is, una ta dere, 3 sine 30 degrees. Sunod, second, minus, kay paubos ang iyang component, 4/5 times 5 kilonewtons. Paubos gyapon ni minus 4 kilonewtons. Since this is going down, this is vertical nga pag go down, then wala na ta nag cosine, chuchu. Okay? So your FRY, negative 6.5 kilonewtons. Negative siya because ang atong gi-assume nga direction sa positive is going up. So therefore, to make it positive, this is 6.5 kilonewtons going down. Okay? So now we have here the components of the resultant force of FR. Okay? So karon, what is the magnitude of this one? How to get the magnitude gani? All we have to do is to use Pythagorean theorem. Kaya diba, ang pasabot lang ana, this is your point O, and you na-determine imong FRX as 5.598, and ang imong FRY is 6.5 kilonewtons going down. Okay? So, asa gani ang magnitude sa resultant ani? This one is the magnitude of your resultant. Right? This is your FR. This is your FRX and FRY. Okay. So, to get your resultant, the magnitude of your resultant force, all you have to do is to use Pythagorean theorem. 5.598 squared plus 6.5 squared. So, your magnitude here is 8.58 kilonewtons. And this is not yet a vector because we need the direction. So, how can we determine the direction? Diba? We just know that this one is a triangle. This is 6.5. And this is what we are looking for. So, all we have to do is to opposite over adjacent. So, that is theta is equal to inverse tangent of opposite. This is 6.5 over adjacent, 5.598. And therefore, your theta is just basically equal to 49.3 degrees. Okay. So, therefore, this one is 49.3 degrees. Okay? So, are we done? Not yet. Why? Why? Because ang ato pagi solve is ang resultant force sa aning tulo ka forces. And then, di ba? Principle of transmissibility. We can transfer the resultant of these three forces into to your point O. But we are not done yet. Why? Because these three forces still creates a turning effect about point O. So we still have to determine the moment of these three forces about point O. So that is our second nga pangitaon. Okay? Nakita namin nato. So ako lang sa ibutang diri. 8.58. Okay? Sige, let's proceed. So, again, we have to determine the moment of the three forces about point O. So, therefore, summation of moments about point O. Let's assume that the direction counterclockwise is positive. So, this is equal to, una ta sa 3 kilonewtons. So, ato unahon ang x component sa atong 3 kilonewtons. So, this is 3 cosine of 30 multiplied by the moment arm. Pilang moment arm? 0.1 meters. Lang, ano naman na po na. Diba? Nagpaspasay na taha kay daghan nag-isolve. So, this is your x component of your 3 kilonewtons. And this is your moment arm of your 3 kilonewtons. Yan na. Next is, sige, ang y component na pod. Wait, is this positive or negative? Unsa man iya ma-create nga moment? This one here creates a clockwise nga direction. So, this is negative. So, kanina punta sa y component na punta. 3 sine of 30 multiplied by the moment arm of given 0.2. Wala lang ni natungod ha, pero tungod na sila. So, what is the sign? Is this positive, negative? So, this one creates a counterclockwise direction. So, this is positive. Dirita sa 5 kilonewtons. Una na punta sa x component. So, ang iyang x component, does it create a clockwise or counterclockwise direction? This one creates a counterclockwise direction. So, this is positive. Plus, x component 3/5 of 5 multiplied by the moment arm of 0.1 and y component na punta, y component. So, this one creates a clockwise effect. So, negative 4 over 5 times 5 moment arm. So, ang moment arm ani, padiri man ang atong 4. So, say distance ani, from here to here. So, 0.2 plus 0.3. So, 0.5. And lastly, 4 kilonewtons. So, wala naman siya x component. So, ang y component na atong gamita, ang pangitaon. So, this is positive or negative. This one creates a clockwise direction. So, this is negative. Negative 4 kilonewtons times the moment arm of 0.2. And all of this will be equal to your resultant moment. So, therefore, your resultant moment about point O is equal to negative 2.46 kilonewton meter. And this one is creating a counterclockwise direction. So, to make it positive, 2.46 kilonewton meter rotating clockwise. So, this is your moment, the resultant moment of the three forces. Sige, let's draw this one again, but instead of showing these three forces, ato siya i-simplify sa katong atong na-solve. So, this is your point O. And we have here our FR. And our FR has a magnitude of 8.58 kilonewtons. And we also have a moment that is rotating clockwise, a moment of 2.46 kilonewton meter. So instead of looking at this one, this has multiple forces, we can summarize this one into this kind of force. And both of these two systems I am showing you right here have the same effect na gibuhat sa atong plate. Okay? Same effect. Okay? Understood? So that is how you just simplify forces into one single force and a moment. But do you know, we can actually simplify this one further. Ibaba mo, ana. We can simplify this one further by removing the moment. And how can you remove the moment? We will move the force into a certain distance. We will move the force into a certain distance, and kanang distance, ning multiply nimo, it will create the same moment. Gets? So, di ba, you have the equation moment is equal to force times distance. So, since you have the force and you have the value of your moment, you can determine the distance. Sige, let's try. So, in this case, D is equal to M over F is equal to 2.46 kilonewton meter divided by 8.58 kilonewton. So your answer here is 0.29 meters. Nakasabot. So, di ba, ato to simplify into this one, ato gi-create kay resultant force and then iyang resultant moment. But instead of just staying it here, ato pa siya gi-further og simplify. Kay di ba kung ato ibutang atong force at a distance from point O, we will create a moment. And then we have the value of your moment and you have the value of your force, then you can determine the distance. So therefore, this one is 0.29 meters. So, kani, ug kani, they create the same effect. And this is the most simplified nga system sa aning atong complicated nga system before. Okay? So, ingana lang. And you should always take note that this one is perpendicular. Sige, let's have another example with the application of this very simplified nga atong bago pa na learn nga concept. Okay? So, wala lang nato siya gi-summarize into its resultant force and resultant moment, but we are summarizing your system of forces into one force that is directed at a certain distance from a certain point. That creates the same effect, just like before. Okay? So, ganahan ba yan? Just like before. Let's have this another example to further simplify multiple forces into a single force. So let's say, for example, I have this jib crane. This crane has 1, 2, and 3 forces. Okay? And what we're going to do is to simplify this system. To simplify these 3 forces into one force. Okay? But instead of acting at this point, point A, ato pangitaon ang resultant aning tulo ka forces kung ug asa siya nag-act along this column AB and along this boom BC. Okay? Ang atong goal, ako i-drawing atong goal ha. Ang atong goal is to simplify that one into a single force. So puntahin na natin single force and ato na i-locate kung asa na siya na nag-apply sa imong boom AB and boom BC. So that is our goal. Kaya diba, ato naman siya further simplify. Wala na ato nagbutang sa resultant force dire, kaya na, diba naman ay moment, pero ato gitangtang ang moment, kaya ato gi-move siya at a certain distance from the moment axis. Okay? Sige, let's solve. What are we going to do first? Our first goal is to determine the resultant force of the 3 forces. So, FR. But instead of having your FR, ato ibutang ang components atong pangitaon. FRX. Assuming that your FRX is going to the right, ang positive, is equal to summation of forces of along the X. Equals to what? Puros man negative. Una ta sa 250. So, minus 3 over 5 times 250. Then, 0. Okay, wala siya X component. And, di na ta mag cosine or mag slope since it is moving horizontally. So, minus 175 pounds. Okay, so therefore, your FRX is basically equal to negative 325 pounds. But since we assume that this one is moving to the left, then to make it positive, 325 pounds moving to the left. Okay? How about your FRY? Going up. Positive. Equals to. Diretso na tad, nata magputang ani. Okay. Una ta sa 250. Minus 4 over 5 times 250. Sakto. Minus 60. And this is horizontal, so it has no y component. Therefore, your FRY is just basically equal to negative 260 pounds. And we assume that the positive is going up, but we found out that our answer is negative, so we had to change the direction. 260 pounds going downwards. Okay? Have to determine the magnitude of the resultant force. We still only have its components, so we should look for the magnitude of the resultant by using Pythagorean theorem. 325 squared plus 260 squared. So the magnitude of our resultant force is 416 pounds. How about its angle? Ang ato lang nahibawaan is your 325 is going to the left and your 416 is your 260 is going down. So we have to determine the angle of your resultant. How can you get this angle? Opposite over adjacent. That is inverse tan of 260 divided by 325. So therefore, your angle is just equal to 38.7 degrees. Okay? So this is 38.7 degrees. Unsa man ini siyang itsura inig drawing nato na dire. Ato pag i-assume nga naa dire ang atong FR. This is your FR and this is directed at your theta of 38.7 degrees. But still, we are looking for the moment. Mangita pa ta sa moment. So, this is your MR. But, since ato man further simplify, then instead of having your MR, we will move your FR along the bar to have that D. Okay? And your another D. Understood? Ayaw mo ka-confused ha? Kay akong pasabot ani, kung ganahan nimo i-simplify ang imong tulo ka forces into one single force, ang first question, if ang kaning single force is located on this column, and then the second question, if the force is located on the boom. Okay? So duha ang gipangayo ani. Kung na-locate siya sa atong column, and second, kung na-locate siya sa atong boom. For us to be able to solve it easier, let's solve for the resultant moment. Okay? Okay. Solve ta sa resultant moment. MR. About point A. Assuming that the direction is counterclockwise ang positive. Equals to. Okay, momenta. This is your point A. Mong momenta, unahon na to ang 250 gihapon. So, una ta sa x component sa atong 250. That is 3/5 times 250. Moment arm of, this is your x component. So, what is the distance? 11 feet. Is this positive or negative? This one creates a morning iyang x component. This one creates a clockwise, a counterclockwise na direction. This is positive. Next, y component. Iyang y component, is it positive or negative? It creates a clockwise direction, so that is negative. 4/5 times 250 times distance 8. 5 plus 3, 8. Then, dirita sa 60. This one creates what? Positive or negative nga moment? This is negative gihapon since it creates a clockwise nga rotation. So, 60 times moment arm of 3. And lastly, dirita sa 175, does this create a positive or negative nga moment? So, this is your point A, and this one creates a positive nga moment. So, plus 175 times moment arm of 5. Okay? So, therefore, your resultant moment at point A is equal to 745 pound-foot. And Since this is positive, then sakto atong assumption that it is rotating counterclockwise. Okay? Oh, ganun lang. So, now, adto ta sa second nga pangutana. Adto ta sa una sa second nga pangutana. Letter A. Kung atong resultant force is 416 pounds and our resultant moment is 745 pound-foot. So, nana siya diri, di ba? And then, 745. And this is 416. So, to further simplify this one, you have to first solve sa distance from here to at a certain point. Let's call this one y, kay y-axis man. And para matangtang na to ng 745, unya, ma-move na to ang 416 at that location to further simplify our problem. So, ang atong gipangita is ang y. Sama na to pagpangita. We have the formula, moment is equal to force times distance. But in this case, ang atong pangitaan is ang y. Aya, sige. Distance. But we know, this one has two components. Kaya diba, ang distance nga pasabot ana kay kana. Pero di man ta ganahan ana. Ang ganahan nato kay ang distance along the column man, which is ang imong y. So, this is moment is equal to fx times y plus fy times x. Pasabot ana. This is your y. And ang sa man imong x, di ba? Naman kay component ani. This is your x component and this is your y component. Ang imong y component, this one coincides with the moment axis. So therefore, this is 0. And kanina lang imong mabilin, fx times y. This is your y, and we still have to determine the x component, which is we already have solved previously. 745 pound-foot is equal to what is your fx? Your fx nga imong na-solve earlier is 325 pounds. And now, you're looking for your y, so that is unknown. So therefore, your y can be solved and you'll get a value of 2.29 foot. So therefore, ang imong 416 pounds should be located 2.29 feet from point A to this portion along your column AB. Napatay second question, how about kung along siya sa imong BC? Okay? This is your 416. And we have to determine this distance. Okay? Same application. 745 pound-feet is equal to, ito naman eh, di ba? We still have a component, dira og dira. And this is, dirita nag-moment. Dirita nag-moment ha? So it will happen. Kani, positive ni siya because it is rotating counterclockwise. So therefore, your x component of your 416 is positive because it creates a counterclockwise. So, that is 325 times moment arm of 11. Diba? Okay, this is 11. Okay? Minus, this one creates a negative nga moment because it is rotating counterclockwise. So, minus, what is the y component? Y component is 260 pounds times this distance that you still don't know, which is x. So therefore, you can get that your x value is 10.9 feet. So these are your final answers. Okay, so therefore, this value here is 10.9. Okay? This one, and this one creates the same effect. Okay? This one has 3 forces, but ato siya gisummarize into one force located at a certain distance from point A. This one also one force, the distance from point A, but all of these three again, they have the same effect sa ning atong jib crane. Understood? Okay, so now you have learned how to reduce a series of forces into one resultant force acting at a distance from your moment axis, or where your object might turn. How about if we have a new kind of loading that probably you are not yet familiar of? Let's see this one. How about if you have this cantilever? Again, a cantilever is a beam that is only supported at one end, and it is fixedly supported at that end. Okay? So, how about you have this kind of loading? Kung ingani ang imong load, what does this mean? This is what you call a simple distributed loading. Because, as you can see, your load dere will depend on asa siya nga position sa imong bar. Or basically, it has an equation. So, let us say your weight is a function of x. Okay? Again, your weight will depend on what is the location of your x. On some example, aning distributed loading. This one is a distributed loading because if you're going to look at the side, so this is your chalk box, and mauni ang imong loading sa imong chalk box. This is distributed because the load is distributed on the area of the box. But since in this topic we are only focusing on 2 dimensions, so we will just be talking about loading that is exerted on a single axis. So diha lang ta mag-focus. We will talk about rectangular distributed loading later on because this is much easier compared sa atong kaning curve nga loading. So the question is, how can you simplify this curved loading into a single force? Okay? What are we going to do? We have this equation to get down your resultant force. Okay? Again, the goal here is to simplify this distributed loading into one single resultant force. Okay? So, also in this case siguro, if we want, kung ganahanin ako i-simplify ang distributed loading into one single force, then ato kuhaon ang weight ani nga butang. And then, it should be acting on just one point of this object. Nga na lang atong goal. Okay? So, for us, we have an equation. In order to solve for the resultant force of this distributed loading, all we have to do is to integrate. Integral of your Wx dx from, along with the whole length of your load, of your distributed load. So, ingani itong buhaton, we have to integrate this equation, the equation of the line of your load, and integrate it along with the length of your distributed load. Or basically, to make this one much simpler, let us imagine in order for us to determine the resultant force of this one, just imagine we are getting the area of this curve. Same goes diri sa atong rectangular nga load. For us to be able to determine the resultant force of this rectangular nga load, all we have to do is to just determine the area of that rectangular loading. Yan na lang. Okay? So, probably you have learned it on your calculus nga para magkuha ka sa area ani nga curve, you have to integrate it. So, ato lang nang gi-apply diri sa atong diri nga situation. Now, how is this formula created? Okay, let's go back. Let's go back to our principle anang calculus. Diba you have this curve? And then, in order for us to get the area of the curve, we need a very small strip. Or we will call this one a differential element. Diba? This is your differential element. And this one is composed of many differential elements. Daghan nga mga rectangle, pero nagpili lang ta og isa. Okay? And to get the area of this curve, all we have to do is to sum all the rectangles from here to here. Diba? So, given now that the width of this one is dx and the height of this one is wx, then to get the area of this rectangle, unsa man na? Again, kani na siya width of dx and kani na siya height of wx. So, to get the area of that rectangle, or this is your dA, okay, that is your dA. Muna differential area nimo, saan nga differential. So, to get your dA, length times width, that is wx times d of x. Okay? So, now, if you are going to get the area, you have to integrate it. And to integrate the whole area, and this one is to integrate the whole length. So, mao na, dira na-create ang atong formula nga wx dx. And kay diba, when you integrate this dA, you will get this whole area. And again, this whole area of the curve is equal to the magnitude of the resultant force. Okay? So, timan ina. Ingana lang ang shortcut, ang concept ani nga kuan. No problem. To get the resultant force of this curve, all you have to do is to get the area. And to get the area of this curve, all you have to do is to integrate. Okay? Wala pa tanahuman because ang ato lang gipangita kay ang resultant force. We also have to determine at what location ang kanang resultant force na locate from this curve in order for it to have the same effect sa distributed pa ang katong kuan, katong load. Okay? So, unsaan man na? We have another equation, and that is what you call the x bar. And basically, your x bar only has a formula of the integral of x dA over the integral of dA. Okay? Or, since your dA is equal to wx dx, so it is just simply x wx dx over integral of wx dx. So, mo nang imo pag-determine sa location sa imong resultant force from a certain point. So, in this case, this is your x bar. So, basically, in this case, ang kani imong x bar is actually the centroid of your curve along the x axis. The same goes, your FR here, ang x bar nimo dire is located at the centroid of your rectangle. So, if you have a rectangular nga distributed nga load, you can just immediately automatically say that your FR is exerting a force at the center of that rectangle, ang iyang resultant. Pero, if you have a curve, then you still have to integrate it. Okay? And now, what if you have a triangular loading? How will you get the FR of this one? Diba? Ang FR is equal to the area of the triangle. So, therefore, all we have to do is to 1/2 base. Let's say this is your B base, and this is your height, 1/2 BH. So, base times height over 2. Mao lang na ang atong resultant force sa atong triangle. And then, the question is, asa man na siya nag-act? Asa na siya nag-act? Ang atong FR. Always take note, we have this rule. Nag-act na siya if this is 3 meters. Always take note that your FR is always acting 1 meter from the largest end and 2 meters from the smallest end. Or basically, that is 1/3 from the largest end and 2/3 from the smallest end. So, nga na lang ang atong sa triangle. Sa atong rectangle, to get the FR, atong lang buhaton is base times height. So, base times height lang. And then, ang location sa atong x bar is just equal to 1/2 of the base. Nga lang. So, balik ta dire. Ang location sa atong x bar dire sa atong triangle. So, from the smallest is 2/3 times base. Kung from the small end. And it is 1/3 times base if it is from the highest end. Pasabot na kung highest end, mo ning highest end, kaning from the small end, mo ning small end. Ganaw. Let's try to solve a problem with regards to solving for the resultant force. Taas ang kahit anong lecture, no? Kapoy mo may nag-lecture. We have this problem. We have this beam. This beam is subjected to a distributed loading which is curve. And this curve, ang pinakadako daw nga end sa curve is, kani siya is 240 Newton per meter. Take note di ay ha, nga ang unit sa atong distributed loading is always Newton per meter. Okay? Because, unsay pasabot ana? 240 newtons siya per meter. Pasabot ana. Okay. And your curve has an equation W is equal to 60x squared Newton per meter. Okay? So, equation ang gihatag sa atong distributed load. Now, the question is, determine the magnitude and the location of the equivalent resultant force acting on the shaft. Okay? So, pangitaon nato ang FR og asa na siya na-locate from this beam. And ato lang isulti nga from this point. Okay? Okay. So, unsa man atong buhaton? We have to first know what is DA. Di ba? DA is your differential area. Maghimo lang ka og gamay nga rectangle diha. That is your rectangle. Okay. And what are you going to do? So ato gipadako ang atong rectangle. This is your DA. Okay. So your DA is a rectangle, kay di ba? Rectangle man na sa atong nahibaw-an sa atong calculus sa una. So what is the width of your rectangle? This is dx, right? Di ba? Kay ang iyang thickness kanon na is dx. How about its height? Height ana, natay equation. That is 60x squared. Mo nang height sa atong DA. Okay? So therefore, your DADI is equal to 60 x squared dx. And now we have to determine the resultant force. And we learned that your FR is equal to the area, which is equal to the integral of dA equal to integral of 60 x squared dx. And this is from 0 to the length of this beam. Okay, di ba? Dire man siya nag-act throughout the length of the beam. And your length is 2 meters. So, unsa gani may tabo, inig-integrate na ni? May muna siya, 60 x cubed over 3. And then, this is from 0 to 2. Right? Okay. And that is 60 divided by 3, 20. 20 times 2 cubed minus 20 times 0 cubed. And your FRDI is equal to. So that is 160 newtons. Okay, of course, this is 0. So, to integrate, then the answer of this one is 160 newtons. Therefore, your FR here is 160 newtons. Okay? And now, the question is, where is it located? Diba? We have learned that we have the equation x bar is equal to integral of x dA over integral of dA. And we knew that your integral of dA is equal to 160 newtons. Diretso na taana. So, kanina pong x dA. Saan man na siya? Balik ta. Integral of x times sa itong atong dA, mo ni atong dA. This is very important. Dapat ma-formulate ninyo kanunay. Okay? Kaya again, your dA is just the differential area of your rectangle, which is your height times your length. Di ba? Kaya maning, di ko kay bawa mo tawag ani, length ba ni siya kay paing ana or maning length. Pero, mani. Okay? So, height times width. Na lang. Okay? So, mo na height times width. Okay? So, balik ta. 60 x squared dx over 160 newtons. Ito sa integrate ang babaw. It will happen 60 x to the 4 over 4. That is from 0 to 2 over 160. Ito na diretso ha? 2 to the power of 4. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 divided by 4, 4. So, this is 60 times 4 over 160. 6, 12, 18, 24, 240 divided by 60. Divided by 160, that is, your x bar is equal to, di na ako ka-divide, that is 1.5 meters. This is just basic. This is your integral calculus. Do you have integral calculus na? I assume your integral calculus is a prerequisite for you to be able to reach this subject. So, what does this mean? Ang kaning atong curve, we can simplify this one into its resultant force, 160, which is acting 1.5 meters from the left of this beam. Understood? So, you have more problems on your modules and you can practice those problems as well. Sayon lang kayo. If you know how to integrate, then good. If you don't know how to integrate, then you have your calculators for you to be able to integrate. Your calculators are very much helpful when dealing with this kind of problems. So that's it. That is all about our force system resultants. In this topic, we have tackled on how to simplify multiple loads into one single load, and we also have simplified a distributed load into a single load. We will have more of these things on the later parts of our subject. So don't worry. Kay magbalik-balik na taan ni pohon. And maanad na mo og solve mi ani. So as a summary for this lesson, we have simplified all those multiple forces and distributed forces into one single force, acting at a distance from a point of reference. Do you have any questions? And if you have some things that you still don't understand, then there are so many tutorials in YouTube, and there are so many references that you can read in order for you to learn more. And especially, you have to practice. Okay? So, thank you for listening. Thank you for reaching up to this point of listening to our lecture, which is very, very long. And I hope to see you again on the next week. Wow, next week is long exam. So you better study na, and the coverage will be from the start until this topic. So you have a lot of things to study. So I hope that you will review as early as now. Okay? So, bye.